Dear listeners, a very good afternoon and welcome. Today, we'll have a session on digital image processing, that is on image enhancement technique. Today, we'll discuss about image enhancement techniques. In today's world of advanced technology, where most of the remote sensing data are recorded in digital format, almost all image interpretation and analysis involve some element of digital processing. Therefore, digital image processing software should provide us with three basic functionality. The very first function that needs to be performed on the image is pre-processing of the data, which includes removal of all kinds of error from image. Second function is image enhancement, that alters the impact of the image on the viewer by improving its appearance quality. And the third function that is required to be performed on image is information extraction. In this session, I will talk about one of the image enhancement techniques, that is basically the modification of image to alter its impact on viewer and analyst who is reading the image for better visual interpretation or even automated classification of targets and features entirely by computer. In order to process remote sensing imagery digitally, the data must be recorded and available in a digital form, suitable for storage on a computer tape or a disk. Obviously, the other requirements for digital image processing is a computer system, sometimes referred to as an image analysis system, with the appropriate hardware and software to process the data. In computer graphics, image enhancement is the process of improving the quality of a digitally stored image by manipulating the digital number of a pixel. It's quite easy, for example, to make an image lighter or darker, or to increase or decrease contrast of the image for having better visual interpretation and understanding of the image. So, this lecture will introduce you to the most common forms of processing that needs to be performed before Earth observation images, that is satellite images, can be used quantitatively to characterize the map features of the Earth's surface. The various topics that we'll cover in this chapter or in this session are introduction about digital images, image contrast, contrast enhancement techniques like linear and nonlinear contrast enhancement, image histogram equalization, gray level enhancement, and band ratioing, etc. After completing the course, the students will learn the various methods of contrast enhancement and image enhancement, which help in the modification of images to make them more suited to the capabilities of human vision. So, let us begin with what actually image enhancement is. Image enhancement is concerned with the modification of the images to make them more suitable in appearance to the capabilities of human vision. It is done to improve the visual interpretability of an image by increasing the appearance difference between the features in the scene. Image enhancement, as mentioned earlier, alters the visual impact that the image has on the interpreter in such a manner that it improves the information content in the image. Computer-assisted enhancement aims to visually increase the slight radiometric or spectral difference to make them readily observable. Therefore, one of the aim of image enhancement is to intensify the slight difference for better clarity of the picture or the image. And this enhances the separability and contrast between the interested class or features in the scene. A wide range of image enhancement techniques at the dispense of analysts are categorized as either point or local operation. So, first let us understand what this point operation and local operation are on the image. Point operation. Point operation modifies the brightness value of each pixel in an image data independently, whereas local operation modifies the value of each pixel based on neighboring brightness value. These operations calculate a new pixel value based on the values in a local neighborhood. Selection of any image enhancement method or combination of methods for any particular application is an art and a matter of personal preference. Before applying any enhancement operations on an image, it must be restored and the noise must be removed from the image. Image enhancement techniques include gray level and contrast manipulation, noise reduction, edge sharpening, linear and non-linear filtering, magnification, pseudo-coloring, and so on, just to mention a few. First, let us understand what contrast in an image is actually. Contrast in visual perception of the real world can be determined by the difference in the color and brightness of the object and other objects within the same field of view. Or, elsewhere we can say, it is the distinction between the darkest and brightest area in the image. So, contrast in an image generally refers to the difference in luminance or gray level values in an image and is an important characteristic for image interpretation. Contrast in an image can be defined as the ratio of the maximum intensity to the minimum intensity over an image. And mathematically, it can be expressed by the given relationship as shown in the slide. C is equal to intensity maximum divided by intensity minimum. And this contrast ratio has a strong influence on the resolving power and detectability of features on an image. Larger the contrast ratio, the more easier it is to interpret the image. Now, since the image quality is a subjective matter and can vary from one person to other, thus there is no defined thumb rule that a particular single technique may produce the best result. Contrast enhancement techniques extend the range of brightness value in an image so that the image can be efficiently displayed in a manner desired by the analyst. The digital number values in a scene are expanded over a wide range in order to increase the visual contrast between the two different areas of uniform digital number values. This enables the analyst to discriminate easily between areas initially having a small difference in density. Very often, relatively low contrast images form because of similar reflectance of different materials throughout the different ranges of wavelength available for remote sensing. When image data are acquired, the detected energy does not necessarily fill the entire gray level range that the sensor is capable of. And this can result in a large concentration of values in a small region of a gray level, producing an image with very little contrast amongst the features. To produce an image with the optimum contrast ratio, it is important to utilize the entire brightness range of the display medium, which is generally film. As mentioned earlier, since it is a subjective matter, so it depends on the analyst to choose the operation on the input image to fulfill the requirement, although sometimes the enhancement product or enhanced product contains only a fraction of information of the total information contained in the original image. Contrast enhancement is also sometimes referred to as contrast stretching. The sensitivity range of any remote sensing detector is designed to record a wide range of terrain brightness from black basalt plateau to white seabeds under a wide range of lighting conditions. But there are only a few individual scenes that have a brightness range that utilizes the full sensitivity range of these detectors. To produce an image with the optimum contrast ratio, it is important to utilize the entire brightness range of the display medium. Therefore, the main objective of the contrast stretching is to expand the narrow range of brightness values typically recorded by a sensor over a wide range of gray values, resulting in an output image with enhanced feature contrast. So let us look at the various methods of contrast enhancement. The techniques available for contrast enhancement are linear contrast enhancement techniques and non-linear contrast enhancement techniques. Thank you.